let's take a look at that. All right. So today we're going to talk about using reference angles. If you want to keep that paper nearby, we may be adding more onto it here. Okay. So reference angles will be our main focus here, but also the rest of the trig ratios as well. Okay. Reference angles and the rest of those trig ratios. Okay. So when it comes to evaluating something, all right, so for example, let's say that we want to evaluate sine of 150 degrees. Okay. When it comes to evaluating sine of 150 degrees, all right, we can look at that 150 degrees on our little unit circle here, right? And while, yes, 150 degrees is referring to the angle that's made starting at 0 and wrapping all around here, right? This is an obtuse angle because it's greater than 90 degrees. We did not come up with the coordinates for 150 degrees using an obtuse angle, right? We're talking about trigonometry here. We're talking about right triangles. We need a right triangle. You can't make a right triangle with a 150 degree angle. So instead of using the 150 degree angle here, we talked instead about using like the 30, 60, 90 right triangle here because this 150 is 30 degrees back from 180. Okay. So instead of using the full 150 degrees here, which is the actual angle, we're going to use the reference angle, which is just its distance from the x-axis. So it's 30 degrees back there. Okay. So evaluating the sine of 150 degrees is actually close. Okay. I'll write this. This is similar to sine of just 30 degrees. Okay. Because it's the reference angle. It is 30 degrees away from the x-axis. So we're going to use sine of 30 degrees to evaluate that. Okay. And so using this strategy, you can maybe, well, we'll just hold off on that for right now. Okay. So evaluating sine of 30 degrees. Okay. So it's like, all right, now we just need to remember what sine of 30 degrees was, right? Remember that all of the coordinates that we came up with yesterday well, almost all the coordinates, except for the stuff on the axes. But most of the coordinates we came up with yesterday came from those two special right triangles. And that's what we want to have to refer to when we're evaluating trigonometry. Okay, so this is part of the method here. When it comes to evaluating trig functions without a calculator, you want to start out with drawing those two special right triangles. Okay. So the 45, 45, 90, right, was one of them. Okay. And there's lots of ways to write this special right triangle. Like yesterday, all of the right triangles had a hypotenuse of 1 because that was, we were all on the unit circle. But that 45, 45, 90 relationship, that can occur, like there are similar triangles to that. So for example, I instead like to leave it like this. Okay. Again, the original relationship we saw yesterday was 1 was the hypotenuse, and then we had a root 2 over 2 and root 2 over 2 for the two sides. Okay. But if you multiply all three of these sides by root 2, okay, using like an idea of similar triangles here, well, you then end up with root 2 for this side. Root 2 times root 2 is just going to be 2. Over 2 then will be just 1, and then root 2 times root 2 will be 2 over 2 will then be 1 as well. So you can see it's a similar triangle to what we did yesterday. Okay, I just find the math to be a little bit easier when you draw that reference triangle. Okay. Likewise, you also use a 30, 60, 90 right triangle too, right? And
And so it's important that you draw these down accurately. Okay. And if you remember the relationship from yesterday, again, we're going to use a similar relationship, not the exact same. Again, the hypotenuse was supposed to be 1 yesterday because we were on the unit circle, but I'm going to use a similar relationship here. I'm going to say that the side opposite the 30 degrees is 1, the hypotenuse is 2, and then that would make the side opposite the 60 be the square root of 3. Okay. Again, we're using these triangles because these triangles helped us to get almost all of the coordinates for our trig, for our points in the unit circle yesterday, which we then saw, those points, right, gave us both sine and cosine, the values of sine and cosine of those angles. Okay. So, this is what you will have to memorize if, again, you choose to use this method to help you evaluate trig. You'll have to memorize these. You have to be able to regurgitate those. Okay. Remember them. And now, when it comes to evaluating the sine of 30 degrees, we also need to remember one more thing, I guess. Well, I guess a couple more things, right? But SOHCAHTOA, right? That's helpful. We hopefully have that down already, though. Okay. And CHOSHIKAO, too, for the other ones, because we're going to get to those. So, sine of 30 degrees. Here's what we do, right? We go to that 30 degrees in our special right triangle right here. We use sine. What is sine? Sine is opposite 1 over hypotenuse 2. So sine of 30 degrees is 1/2. Okay. So sine of 150 degrees will also be 1/2. And that's pretty much it. Okay. Just using reference triangles there. The one thing we have to keep an eye out for is that sine of 150 degrees is important for us to recognize in what quadrant that is located. Okay, so 150 degrees is in quadrant 2. Okay, sine is positive in quadrant 2. How do we know? Well, in quadrant 2, the y values are positive. Remember, sine is a y value. Okay, or sine matches to the y values there. So the y values are positive in quadrant 2. Sine will be positive as well in quadrant 2. Okay, so there's your answer. Sine of 150 degrees equals 1/2. Okay. If you want a little thing to help you remember, like which trig functions are positive where, okay, there's one other little thing you can draw for yourself too, if you like. Okay. I don't know, people have a different way. I remember when I was in high school, I just did like acts. Of course, that's going like a weird way around the coordinate plane there. Other people remember all students take calculus, right? You can remember however you want to with the different letters there. Okay. What do those letters mean? It means in quadrant 1, all trig functions are positive. In quadrant 2, sine and its reciprocal cosecant are positive only. In quadrant 3, tangent and its reciprocal cotangent are positive only. And in fourth quadrant, cosine and its reciprocal secant are positive. And again, why does it work out that way? Well, because in the second quadrant, the y coordinates are positive, but the x coordinates are negative. So that means like cosine and its reciprocal secant will be negative because, again, negative x coordinates. But also tangent will be negative, and you'll see why that is in a second here too. Here, both tangent and cotangent are positive, and here cosine's positive. Why? Because the x coordinates are positive in the fourth quadrant, but the y coordinates are negative. So only cosine and its reciprocal secant will be positive there. Okay, let's try another one here. So let's find cosine of 300 degrees. Cosine of 300 degrees. So again, it's important for us to identify here what is the reference angle. That is, what angle brings us closer, or what's the angle that takes us, the smallest angle that takes us back to the x-axis, I guess I'll say. Well, if you go back here to our little unit circle, there's 300 degrees, right? So again, 300 degrees, we can think about it going all the way around this way. But really, how far is it from the x-axis? 60 degrees. And so evaluating the cosine of 300 degrees, we can actually just evaluate the cosine of 60 degrees. Okay? How do we evaluate the cosine of 60 degrees? You go to your reference triangle here. Cosine is adjacent, 1 over hypotenuse, 2. So cosine of 60 is 1/2. Since we're in the fourth quadrant here, cosine will be positive. And so we're just going to end up with the cosine 300 degrees is positive 1/2. We don't need to change the sign, make it negative. Make this cosine positive there. Okay. Let's try some other ones here. Let's try. Um, Let's see here what I want to do. Go this way. How about like cosine of 5 pi over 4? Cosine of 5 pi over 4. What's the reference angle going to be for cosine of 5 pi over 4? Pi over 4, okay? It actually turns out that with radians, the reference angle is like easy to discover or figure out because it's basically, you can see it right there. It's just going to be the pi over 4. All right, I know there's the 5 pi over 4, but the reference angle, therefore, is just going to be pi over 4. So the reference angle here, yeah, is just pi over 4. And so pi over 4, which triangle is that in? Whichever reference triangle is here is that in? Which one's got pi over 4? The 45, 45, 90 does, that's right. And so we'll pick here, 45, right? Cosine is adjacent, 1 over hypotenuse, root 2. So the cosine of pi over 4 is 1 over the square root of 2, or if you rationalize, root 2 over 2. And so then what should cosine of 5 pi over 4 be? Negative root 2 over 2. Why negative? Where is 5 pi over 4 located? In the third quadrant here. Third quadrant here. Because it's just a little bit more than 4 pi over 4. 4 pi over 4 would be 180. So that's okay. No, you're still right though as far as the sign. Okay, just for the wrong reason. But yeah, tangent. So only tangent and its reciprocal cotangent are positive there. So it would be negative root 2 over 2. And so there's our result. Okay, there's our result. Okay, so again, let's kind of summarize here what we're supposed to do. Let's summarize here what we're supposed to do with these kind of things, all right? So first thing you want to do is just identify the reference angle. Okay. Evaluate the trig function at the reference angle. Okay. Using those triangles or your unit circle if you want to just memorize that. But again, I think the triangles are the best way to go. And then 3, determine the sine, and now we have to be careful because we have two words that sound like sine, but the SIGN, determine the SIGN sign, okay, from the quadrant. Okay, so identify the reference angle, evaluate the trig function at the reference angle, and then determine the sine from the quadrant. Okay, from the quadrant. Bless you. Okay. Now, there are some troubles we do run into, though, some exceptions. For example, what is the sine of pi? Or what's the reference angle for pi? Right? And the answer is pi doesn't have a reference angle, it's already on the axis. Right? Sine of pi is already on the axis. And so we can't use a reference angle idea there. Also, pi, which is 180 degrees, right, that does not fit in any of our reference triangles. But we can still evaluate this, right? What is the sine of pi? 0. Good. It is 0. Okay? Why is pi, if you think about it, pi is here on our coordinate plane. Okay? And so the coordinate there is -1, 0. Sine
being the y-coordinate then is going to be 0. Okay, again, this y-coordinate over here is going to be 0. So sine of pi is 0. Okay. So for like pi over 2 or 90 degrees, for pi or 180 degrees, for 3 pi over 2 or 270 degrees, and then for 0 degrees or 0 radians, or also 2 pi radians or 360 degrees, you'll need to kind of just be able to picture those in your mind as to what the coordinates will be. They're pretty easy to determine, right, because they're just one away in either direction there. So you have to also figure out whether you're in, talking about sine or cosine, right? The y-coordinate for sine, x-coordinate for cosine. Okay. So let's try some more here. So you guys are going to try some. All right. So you guys evaluate these here just to see how we do. Let's have you do cosine of 11 pi over 6 and sine of 3 pi over 2. So go ahead and try those, and then we'll talk about the rest of the trig functions and stuff. Okay. Cosine 11 pi over 6, sine 3 pi over 2. And I'll kind of come around and help. Let me do it here real quick, and then use those reference triangles where appropriate. Identify the reference angles first, and then use those reference triangles as appropriate. Yeah. You always want to refer back to the x-axis. Don't refer off the y-axis. So 11 pi over 6 is 30 degrees off of the x-axis. So you can use 30 pi over 6. Okay. Reference angles are always off of the x-axis. Okay. So please don't refer from the y-axis. Always refer off of the x-axis. Okay. Kind of closest angle that'll get you back to the x-axis. Where it is. Okay? So here's what we should have gotten. Okay, root 3 over 2 and negative 1. All right. Questions on any of that? All right. So let's talk about other angles here. For example, what about the tangent of 210 degrees? Well, what's the reference angle for 210 degrees? How far is it from the x-axis, or how many degrees is from the x-axis? What's that? 150. So reference angle's got to be between like the 0 and 90 there. How far is it? 30 degrees, right? So the 210 is 30 degrees away from 180. Again, I can kind of go back to, let's see, I put that down somewhere, and now I don't know where I put it. Okay. But yes, it is 30 degrees off of the x-axis. Oh, there it is. Hiding from me. Okay. 210, right, is 30 degrees, or pi over 6 from the x-axis there. And so evaluating this is like evaluating tangent of 30 degrees. But still, how do we evaluate tangent of 30 degrees? Tangent is what over what? Opposite over adjacent. So 30 degrees, opposite, 1 over adjacent, root 3. So this is 1 over the square root of 3, or root 3 over 3 if you rationalize it. 210 degrees is in the third quadrant. tangent and its reciprocal, cotangent, are positive there, and so this is just equal to root 3 over 3. Okay? So there's how we can do tangent. How about secant of 45 degrees? Okay, these brand new ones, right? Has anyone seen these before prior to pre-calc? You guys have seen these before? Okay, some of you have, some of you haven't. Okay. So secant is a reciprocal of what trig function? Cosine. I know, it's the dumbest thing, but it's cosine, okay? If cosine is adjacent over hypotenuse, then secant will be hypotenuse over adjacent, just the reciprocal of that. Okay? We don't need a reference angle here, we're given one, so we just go to 45. Okay? And again, cosine is the reciprocal, so it would be adjacent over hypotenuse, but then reciprocal, hypotenuse over adjacent, so it's root 2 over 1. Okay? And again, we're in the first quadrant, so everything's positive there. Of course, you could also just say square root of 2 if you wanted to as well. Okay? Just like that. So those reference triangles are huge. These reference triangles, they went with me into even like calculus and later on too. I would, at the start of any test, if I thought I was going to be doing trigonometry, I put my name and then I draw these little reference triangles here to just be able to refer back to and evaluate trigonometry. All right, we'll do 2 more here and then we'll stop. Okay. And get you guys started on your assignment. Cosecant of 270 degrees. Okay. So again, important here we recognize 270 is not, we can't get a nice reference angle from that. It's going to give us 90 degrees. So this is where we just kind of have to like use our brains, right? Cosecant is the reciprocal of what trig function? Sine. Okay, so if sine's opposite over hypotenuse, cosine will be, cosecant, sorry, will be hypotenuse over opposite. But again, we don't really have trig functions, or we don't really have a reference angle here to use. So instead, let's think about this as 1 over the sine of 270 degrees. Okay, right? You guys said it was a reciprocal of sine, so that's equal to 1 over sine of 270. What is the sine of 270 degrees? -1, and so it's 1 over -1, or just -1. Okay. And again, how do we know the sine of 270 is -1? Well, 270 is on this part of our axis, right? And it's the sine, so it's the y coordinate, so you're down -1. Okay? So there you go. Alright, and then let's do cotangent of 90 degrees. Okay. This will be our last one here we do together. So cotangent of 90, right? Can't get a reference angle for that. Cotangent is the reciprocal of tangent. 1 over tangent, right? But again, how do you do tangent of 90 degrees? Tangent, we don't know. Tangent's not one of the x or y coordinates there. But how does tangent relate to sine and cosine? Does anyone remember? Tangent is what?
Opposite over adjacent.
Okay, opposite over adjacent would be for tangent, TOA. The TOA part, yep. But how can we relate? Does you guys, I feel like you guys have seen this before, maybe not. You guys ever heard that tangent of an angle is equal to sine of that angle over cosine of that angle? Tangent equal to sine of theta over cosine, tangent theta equals sine of theta over cosine theta?
Yeah.
Okay, so that's the case here. Or if that's, otherwise, you also say cotangent of theta then would be cosine theta over sine of theta. Okay, if tangent of an angle is equal to sine of that angle over cosine of that angle, then cotangent would just be the reciprocal, cosine over sine. Okay, so cotangent of 90 degrees is the same thing as saying cosine of 90 degrees over sine of 90 degrees. Cosine of 90 degrees, 0. Sine of 90 degrees, 1. And so we get 0 there. Okay. questions on any of that? All right. So at your 0 degrees or 0 radians, at your 90 degrees, pi over 2, at your 180 degrees or pi, or at your 270 degrees or 3 pi over 2, you're going to have to just kind of like, use the kind of unit circle to help you with that. But anything between, anything that's got a 30 or 45 or 60 degree reference angle, okay, then you can just use those reference triangles to help you with that. Okay. One last question here. If we had done the tangent of 90 degrees, what would have been our answer? If the cotangent of 90 degrees is 0 over 1 or 0, what would the tangent of 90 degrees be? Undefined. 1 over 0 or undefined. Okay, so that is possible with some of these trig functions. Okay, you can get some undefined values there, so keep that in mind too. All right, let's get you guys started with some practice here. Okay, so you can kind of wrestle with this on your own a little bit and see how you can do. And again, I'll be walking around to help. All right, so we get some practice in. On page 316, you're going to be doing numbers 19, 21, 37 to 43, 59 to 67, and 85, 89, odd. Okay? Yeah. Okay. So now we should be able to do, or now you at least have the ability to do, any trig ratio, sine, cosine, tangent, secant, or cosecant, cosecant, secant, or cotangent,